Hi everyone, are you able to hear me clearly and see my screen? Great, great. All right. So do you have any questions before we move forward? Yes, go ahead, please. Do you have any questions for me? All right. Okay. Hi Manu, hi Mohit, hi Ravi, hi Shamit, hi Pradeep, hi MK, RS, and Srini. All right. Great to have you all in the session. So should we start? Great. All right. So there's no question before regarding streaming or stream processing or any other topic so far? All right, no worries. Okay, moving ahead. So we'll do a little recap. Okay, so the topic we were trying to talk about is how to run on the cluster. Although we have talked about the same thing earlier also, let me start recording. Okay, recording is going on. Why don't I see the recording button? Now I can see the recording button. Okay. All right. So it's a very important point which we are discussing. And so we have already discussed this part earlier. So Spark is made up of Spark driver. Okay, this is the Spark driver. Right now, when we were using Spark, we were using the console. Okay, we were using the console. A question from Manu. Kafka topic is like RDD. Kafka topic is like a queue whereby we write something. Kafka is a place which provides many topics to write to. So many people can write to Kafka topic and many people can read from Kafka topic. Okay. So in case of RDD, RDD is not some real entity. Okay, unlike topic, when you write some data to topic, so there is a folder, there is a place where it keeps the data. While in case of RDD, RDD mostly is a representation of logic. Like we say that load this data from here to there, that's a piece of logic. It's not really data, it's the instruction. It's the instruction that is stored in RDD. Okay, but in case you cache it, then RDD is a data. In case you cache it, if you say rdd.persist, in that case, RDD is data. And in case of RDD, we can move forward to jump to various parts of the data, and we can process the entire data. But in case of Kafka topic, we can queue a new topic and we can retrieve the oldest topic. Okay, sorry, we can queue the most recent topic and dequeue, or we can take only the oldest message which we have put into a topic. Okay, While in case of RDD, we can switch to any of the data. Do I make sense? Right. Do I make sense, Manu? Or you can say that the data in Kafka topic is ordered by date time, while in case of RDD, the data is ordered uh, as per our wish. Question from Manu, what kind of data we can write in both? In both, we can write any kind of data. In topic as well, we can write any kind of data. And in RDD also, we can create RDD on top of any kind of data. Okay. The biggest differentiation between RDD and Kafka would be that while RDD is generally created out of relatively static because we are trying to process data, and mostly RDD is more like a read-only kind of behavior, while on the other hand, the Kafka topic is somewhere we have a fast moving data, very fast moving data. So when you have a really fast moving data, you generally go with queue kind of mechanism where you're continuously just writing data on one end and then many people are reading from it. While if you want to process and analyze certain piece of data, then you load that luxuriously into an RDD and then you process it. Okay, did that make sense? Okay, all right. Now, was I able to answer your previous question, Manu? Okay, all right. Let me try to answer Mohit's question. Great set of questions. Please keep these questions coming. And yes, question from Mohit. How does parallelization of queue in Kafka and parallelization of retrieval work in tandem? Parallelization of Kafka and parallelization of retrieval work. Okay, a very good question. Let me take a step back and try to answer this. Okay, so I'm trying to present it. I'm trying to present it in diagrammatic way. Okay, so what you see here is, let's say this is your Kafka queue. Kafka queue has many sub queues inside it called topics. Okay, you can call it, this is one topic and there could be multiple topics. Okay, good. Now, here, the way Kafka does is people would be writing to queues, right? Into many topics. This is first one is first topic, second one is second topic. Now, this topic is itself kind of parallelized. So inside this particular portion, if you kind of take a look at this particular portion, it would be something like or you can say I'll try to draw with a different color. That would, I think, make more sense. So let's just imagine that portion from here to here, here to here, sorry, and let's say here to here. Okay, these portions could go to multiple machines. Okay, while we are putting data, some of the data went to ABC machine, some of the data went to BCD machines. Okay, that's how it works. Okay, this is A, B, and C machines, and this is C, B, and D machine. So this, I'm just trying to explain, it's not exactly this way. I'm just trying to explain that this is how parallelization works. One, the whole topic is divided on multiple machines, and individual sections, you can think of it that parts of the topic are on different machines. Parallelly, the everyone is a backup. Everyone is having backup. So let's say this one is primary, and then there are two copies. This one is primary. There are two. So I'm just trying to give you an example. So this is a parallelization of a different level. The parallelization of a Kafka queue is basically, one form is that there are many topics, so that there is a namespace, abstraction, so that multiple people can use our queue happily without bothering each other. That's the topic abstraction. Then second level of parallel things is that each section, the topic is divided on multiple machines, and each packet, each message the people are writing, they are going into different machines. Okay. All right. All right, so there you can, yeah. Now, next question was that what is the parallelization of retrieval work in tandem? Okay, so here, now retrieval parallelization is not actually much in case of Spark streaming. Retrieval is only once. So okay, how should I describe? Okay. So when we say Spark streaming and when we create a connection to this data, so what happens is we basically empty the entire data. Okay, we empty the entire data from the Spark from here, and put this data into an RDD, a temporary RDD. This is our, let's say, RDD. Let's say this is our RDD. Okay, so using the standard mechanisms, we are able to take out the entire data in a single shot, and then start creating RDD and start processing it. Okay, so I'm not sure if Spark streaming does retrieval parallelly on many machines. Okay, but what it does is it creates these RDD, and then and submits the work, submits the work, and then as soon as it is finished submitting this, it will again do the same thing after some time, and then start creating another RDD. Okay, so this Spark job is working in parallel with another Spark job. Okay, the other thing is a very important point to understand, that at this point, if Spark streaming finds that this queue is empty, there is nothing to process, so it won't create any RDD. Instead, it will wait for some time and then check again if there is some data to process. All right. Okay, did I make it clear, or did I confuse you guys? It's just a little too much to fit it into one diagram. No? Okay. Now, next question is from Manu. Why we are transforming the stream to data frame? This I did not get. So D stream to data frame, where are we doing that exactly? As in yesterday's session? Or do you mean to say that, uh, so at one end we have, okay, yeah. So what is D stream? D stream is a class that is representing this logic. Okay, so every second, so D stream is a concept, as in a class, a object, which on against which you are writing the logic, and inside the D stream, it's basically this RDD, temporary RDD, to which we are continuously delegating the work. So when inside our project, I'll go back here. So here you see this Spark streaming context is creating where lines. This lines is being created by streaming context, right? This SSC, this lines is being created by streaming, okay? Which means this lines will be created, this variable will be created every 1 second, okay? So inside this logic, when we say lines dot print, or and then we say ssc dot start, what's going to do is it's going to take lines, it's going to basically run this, run the logic what you see here, okay? So the words is not really, the lines is not really an RDD. This is not really a RDD. These are the D stream objects. Okay. So what's going to do is when you say word count dot print, word count is also D stream. What it would do is it would internally call these methods on temporarily created RDDs wrapped inside it. Okay, so that's the difference, and that's why, because sometimes you might want to say, let's say there is I think I got your question. Let's say you realize that there is a new function which is there on actual RDD, which is there on actual RDD, right? But it's not there yet in the D stream. Not all functions are available as part of D stream. In those kind of cases, what you would do is you will try to kind of take the base RDD out of this wrapped object and try to apply on that. Okay, so probably that would be the case. That would be the case. All right, because these are the separate classes. Inside it, every time you call flat map, it's calling inside it the actual flat map from RDD. And then when you're saying print, it's calling, it's calling the take on the underlying RDD and executing entire thing. Okay. All right. I hope I was able to answer your question. There's a question from Mersin. On Zookeeper, how to determine which node is for which resource, HDFS or Kafka or ETC monitoring? So you generally do not use, you as in sysadmin or developer, do not use Zookeeper for monitoring. Okay, but if you want to do that, you might have to get a little familiar with with the with Zookeeper. As in, you'll have to know, because the Zookeeper itself does not enforce any kind of standard or any kind of restrictions on the folder names. Whichever service wants to create whatever data models, they can create on top of Zookeeper, and these data models are in the form of Z node or Z nodes. Okay, so that's how it is. So you can basically, let me just do SSH. And what was the name of the, which node is for which resource, HDFS or Kafka? Okay, okay, okay. So you can see that there are so many of these, and most of these are created by the users. Okay, so this Hive server is for Hive server, Storm is for Storm, and there is, I mean, these others are created by people. Okay, all right, all right. All right, so a quick recap. So you have a Spark a driver, you have cluster master mesos. It could be anything. It could be yarn, standalone, or something. So the driver hands over the work to cluster master, okay, and then the work gets executed under inside executor. Here, if it's on yarn, this will be running on inside a container. This whole thing will be running inside a container. Or if it's on mesos, it'll be some other executor unit, and so on. Okay. So the driver is the process where main method of your program resides and runs. When you launch a Spark shell, you have created the driver program. Once the driver terminates, the application is finished. While running, it performs the following. It converts the driver converts the user program. When we say word count.collect, it is this driver program that converts this into tasks, executable tasks. This guy is your butler who takes the orders from you and optimizes the work, and then hands over the optimized tasks to the people, meaning combining multiple things together. Okay, or you can think of this guy is your waiter who is taking the orders and then combining multiple orders together before giving it to the kitchen. All right, and it converts a user program into tasks that are the units of execution, converts DAG into physical execution plan, and it does the scheduling tasks on executors. Okay, now first it converts your logic, your steps, your RDDs into the tasks. Second, it schedules those tasks onto various executors, meaning the in the yarn, if there are containers, it will schedule those there. Okay, so scheduling tasks on executors basically is coordinating the scheduling of individual tasks on executors, and basically here it can also inform the resource manager that is looking for the containers or the executors which are nearer to the data. It also tracks the cached data. If you have cached some data, then basically the individual scheduler, individual executor, this is something done by individual executors. It basically tracks the cache data and uses it to schedule future tasks. Okay, so cache data is handled by executor, but the driver tracks it. Okay, cached data is handled by individual machines, and the the caller or the driver keeps a track of which machine is having which cache data of which RDD and which machine. So accordingly, it places the future task. And the driver runs the Spark web interface at port starting from 4040. It could be 4041 if 4040 is busy. Otherwise, it could be 4042 if 4041 is busy. The individual executors are the worker processes that run tasks for each individual job. So these are basically master slave kind of model. Executors are the slaves. They return the result to the driver, launched once at the beginning of Spark application. So the executors are launched once at the beginning of Spark applications. It runs for the entire lifetime of an application. So if you are running, say, Spark job, the executors will run for the entire lifetime of an application. It provides in-memory storage for cached RDD via block manager. In local mode, driver mode, and executor modes. Sorry, sorry. So let me go back and try to explain what do I mean to say. It runs for the entire lifetime of an application. What does it mean? So when we start our driver, it'll have a container assigned to your driver, and that container will have the lifespan, the executor will be inside that container. As long as your driver is existing, the container is existing. It provides in-memory storage for cached RDD via block manager. In local mode, driver and executors are from the same process. All right. So going back to the diagram, now you can see the diagram. This is your driver. It talks to the cluster manager, and then cluster manager start the executors. Okay. And going back to the cluster manager, it launches the executor. Basically, it's the resource manager of Yarn, and some cases launches the driver too. If you are running your client or the driver inside the Yarn itself, in those cases, cluster manager will run the driver as well. Cluster manager, resource manager, or Yarn, I'm going to use these three words interchangeably. Also, basically, what Spark guys have done, they have created this generic components called cluster manager, which is essentially a kind of plug to Yarn, and it basically can there are different instances of cluster manager for Mesos, Yarn, and others. All right, so it basically is an abstraction on top of Yarn, Mesos, or any other resource manager or cluster manager. So therefore, it's okay to call cluster manager, Yarn, and resource manager interchangeably. Now, this is what happens when you are launching a program. So when you are saying take me is equivalent to Spark Submit. Also, you can say Spark Submit and submit your program. And when you do that, the first request goes to the driver which is on which the Spark Submit is being run. Okay, so driver is basically handling this part. Okay, so when you submit, it's basically calling the driver, and then driver talks to the cluster manager, starts the executor, and then waits for it to stop. Okay, once it's done. All right, you can launch it. I think we have already done this part. Okay, so we have also talked about various modes. Okay, like the master one. It basically indicates cluster manager to connect to. In our case, it is Yarn. Deployment mode, if you say client, it means it need to be run locally. If you want to run inside Yarn cluster, you can say deploy mode equals cluster. Okay, class is the main entry point. We have also talked about this. Name is human readable form, which will appear in the logs as well as in the UI. Jars is the list of jars which you want to hand over to Spark. Sometimes you want to hand over the extra files, okay, just like distribute, cache, and MapReduce. And in that case, you can use dash files as the argument to Spark Submit. And then sometimes you have some package files or Python files which you want to hand over. If you are using Spark Submit with Python program, then you can submit those .py, .eg, or .zip file as an argument. Sometimes you want to enforce how much maximum executor memory can go to. Okay, so suffixes can be used to specify large quantities such as 512 MB or 15 GB of memory. Okay, if you want to change the executor memory. Executor memory is the memory inside container. It should be less than the size constraint on container. Driver memory, the amount of memory to use for the driver process in bytes. Okay, so suffix can be used, this can be used to specify large quantities such as 512 MB or 15 gigabytes. But again, it should be less than the system's allocated memory. All right, so you can bundle, we have talked about it. Okay, and yeah. This also we have talked about. Now, you can run Spark on EC2. Okay. So it has a cluster manager for EC2 inbuilt with Spark. So first of all, you will have to register with AWS, get the private key and secret key. And then once you are done with that, there is this program that it provides Spark-EC2. And then you can submit your program here. Okay. Now, Mesos is similar to Yarn. So to submit to Mesos, you can say Mesos, JK, and then /Mesos. So this is basically the Z node that describes the entry point for Mesos. If you have multiple Z nodes with you, you can basically give a list of uh, 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 zookeepers. Okay, so if you have like 10 servers or 5 servers or 2 servers, so you can give 10 list of all the zookeeper servers, so that in case this one is down, it will use this one, otherwise it will use this one. Okay, so basically you can configure this while launching the Spark. Okay, launching a Spark on Mesos. Okay, if you want to install on your own standalone cluster, what you can do is you can copy the compiled version of Spark to the same locations on all the machines. For example, home, your name, Spark. Set up a passwordless SSH access from your machine to other machines, and then edit the conf/slaves and mention the host name of all the machines that are there in the network. Now start all run this particular command called start-all on all of your machines. Okay, and then check if it's running or not. All right. All right. So you can make one of them as a master and let everybody else slave. Okay. So you can run stop all on master node, and that should be good enough. All right. Now, our general question is, okay, which cluster manager to use? A thumb rule to live with is you start with standalone cluster if you do not have a yarn. If this is your new deployment in your office, you start with standalone, as in you just download Spark and start working on your desktop. To use richer resource scheduling capabilities such as queues, you can use yarn or Mesos. When sharing amongst many users is primary criteria, use Mesos. In all cases, it is best to run Spark on the same nodes as HDFS for fast access to storage. If you are trying to use with Yarn, then make sure that you install Spark on all the nodes having your data nodes. Okay. All right. Although in our case, what we have done is we have done a very simple thing. What we have done is we have, okay. Okay, let me go back. Let me go back. I'll start seeing your questions. So a common question is which cluster manager to use. Should we use Yarn? Should we use standalone? Should we use Mesos? The thumb rule is you start with a simple standalone cluster, whatever is possible, and start using that right away. Okay. Then later on, based on your requirement, if you have just too many users, then you go with Mesos. If you have too few okay kind of users, like hundreds or thousands of users, then you go with Yarn. Okay. Now, when sharing amongst many users is primary criteria, then you use Mesos. Otherwise, you use Yarn if you already have Hadoop. In all cases, it is best to run on the same nodes as HDFS for faster storage. Okay. Also, please note that, very important to note, when we say Spark submit, the Spark need to be installed only on that machine from where you are running this one. Why? Because Spark will Spark Submit is basically a Yarn job, and internally it carries a its own entire thing that needs to be that's needed on every node for running. Therefore, you don't really need Spark to be installed on all the machines of Hadoop in order to run it. Okay. Also, you do not need administrator to install Spark for you. If you have a Hadoop cluster, you can start using it right away for your choice of Spark. Okay, because for Hadoop, for Yarn, it is just another program. All right. And interestingly, most of the Hadoop distributions as of today install Yarn and HDFS together. There is no single installation where we have seen that Yarn is not installed, but HDFS is. Also, the also with the Cloudera and Hortonworks, both of them have started shipping Spark together with Hadoop. All right. Now, a question from Asin: can we Spark submit on Mongo or RDBMS? No, actually. But what you can do is you can read data from Mongo or RDBMS inside your Spark script. Okay. All right. Do I make sense to you? A question from RS: can we get some help during the experimentation process after the course, as there are so many things which need to be experimented? That's right. That's why whenever you have a question, drop me an email at support@cloudxlab or support@nobigdata, either place, and I would love to answer your questions. Okay. All right. And in case you are really badly stuck, okay, feel free to connect. And yes. All right. And okay. So that was how to run on the cluster. I would also like to quickly take you through tuning and debugging. It's nothing much, but just kind of a recap of what we have learned already. Okay. So you notice that while we were creating our own Spark context object, we were constructing conf object and then setting various properties, right? And then we were passing those properties to the Spark context object, this conf object, and then it was giving us SC. And then from here we start our usual process. So if you want to decrease the logs, you can say conf dot the logs and so on, or you can say sc dot set logs. Okay. And if you want to submit a job, if you are submitting a job, uh, right, then also you can specify a lot of arguments, right? For example, we are here saying that the dash dash conf Spark is this. Okay, so please note that when we are specifying this, it does not override what is inside your code. Your code takes the precedence over what you're specifying on the command line argument. Okay, but a good practice is not to hard code here. Instead, use it on the command line. All right. So there are many more functionalities or options or configuration values that you can set. For example, how much executor memory you want to specify. Okay. If your program is really going to do big things on the container, you can increase this value. But this should not be bigger than the container size, because container will otherwise not execute, because this runs, your Spark executor runs inside container, so it should not cross that value. Okay. In our case, this container size is 1 gigabyte, and this one we have set to 256 MB. Okay. And Spark executor cores are basically these executor cores having one configuration of bounding the number of cores used by application. So let's say how many on every executor, if they have multiple processors, multiple cores, you can set those values here. That way, based on this number only, it will decide on every executor how many partitions should be there. Okay, and so this is a second one is the total cores, as in how many total cores out of the entire cluster can it use. Okay, and sometimes you want to start speculation, as in case something dies, let in case something is slow, let it be done by somebody else as well instead of waiting for one person. Okay, so that is the speculation part. So sometimes you would like to not go would like to time out the executors in case you have two long running jobs and there's a somebody is trying running it infinitely. In those cases you can set the timeout. Okay, or your process might have to be killed after some time, therefore there you can run the timeout. If you want to specify more Java options, like when you have JVM running, there are many options like MX, how much heap, how much stack. All of those variables you can set using extra Java options. And extra class path is the class path that you want to specify for your libraries. Okay, so there are extra library path and so on. So inside the executor, there are three parts of execution. One is jobs, task, and stages. Okay, jobs, task, and stages. For example, here we have a text file. We are saying rd.debug string and so on. Okay, so when we look at something, when we say sc.text file, it's basically creating a Hadoop RDD or mapped RDD. Okay, so from Hadoop RDD is creating mapped RDD. When we say call map function, it further creates another mapped RDD. Then again, we're calling filter. It says filter RDD. Then we say reduce by key. It's shuffled RDD. Why? Because reduce by key need to order data from here and then create new RDD. Right? This is what happens in case. This is a RDD lineage graph because mapped RDD depends on this one, and filtered RDD depends on this one, shuffled RDD depends on this one. Okay, so there are many kinds of RDD depending on how the RDD has been created. Okay, if you have created Hadoop, it'll be Hadoop RDD, and it is basically mapped in the sense that it is linked. Now, here there are basically two big differences. One, the features that run on the same machine. Second, the features, the tasks, the stages that require the data from multiple machines. Okay, in these kind of cases, this RDD graph gets translated as part of the physical plan into two parts: stage one, stage two. Why? Because all of this can actually be combined in a single piece of code and run on the same machine. Why? Because of the data locality. Okay, because filtered, when we say filter or map, we don't need data from elsewhere. We just need data from the same machine, right? Therefore, all of these works can be combined together into a single stage to make it faster. Imagine map running on some other machine while filter running on some other machine. There would be a transfer here, right? But in case of reduce by key, there will be, of course, the transfer between multiple machines. Okay. So each task internally performs the same steps, fetching its input, okay, either form the data storage and exist from an existing RDD or shuffle outputs, okay. So this way, and then once everything is done, whatever execution is done, it writes the output, okay. So user, as in me and you, define the DAG or directed acyclic graph or lineage graph of an RDD, right? And actions force translation. When you say action, it converts a chain of RDD into some execution plan, which has stages. Okay, and then these stages are executed inside the tasks, inside the executor. Okay, these uh, stages are what you see here, they get translated into tasks, and those tasks get executed on your cluster inside the container. All right. So you can find the information from Spark Web UI, log files produced by the driver and executor processes. Okay, this is how the UI looks. I have shown you this couple of times. So whenever you are running something, take a look at your e.cloudxlab.com or g. Wherever you are running the driver on that machine, call in 4040 or 4041. Find out the port number. Okay, as I showed you yesterday. Okay, so you can drill down, you can find out what are the storages, stages, and more details. Okay, and yeah, so you can also take a look at the logs. Interestingly, the logs in case of yarn is, if you are the logs are generally saved at the same place where MapReduce logs will be saved. Okay, so when you're running a Spark job, you can actually find your log from Hue inside job browser. Okay, now, the next important part is the with respect to performance. One is level of parallelism, serialization format, memory management, and hardware provisioning. Okay. So by default, a common question is how many partitions? How many partitions would there be? Now here the answer is very, very simple. So generally a single task per partition, okay, will be executed. If you have an RDD which has 10 partitions, there will be one task that will be executed per partition, and hence there will be 10 tasks. Okay. So if you have a single core in the cluster to execute, then there will be one partition per block. If there are multiple cores, then there will be multiple partitions, and both those partitions would reside on the machines containing the data. Okay, so basically there'll be one execution task per partition. If you have too many partitions, okay, if you have too less partition, then of course the cluster will be free. If you have too many partitions, there'll be too much of overhead because of each partition. So to control number of partitions, you can while shuffling, you can say that how many machines it can shuffle on. That one shuffle or sort accept an argument of parallelism. Okay, then there is a repartition accept an argument saying that we can repartition an RDD into new. Now to efficiently shrink, if so sometimes what happens is you have certain data, let's say we had big.txt. Okay, big.txt. All right, let me again define what do I mean. So let's say we had this big.txt and it has many partitions. It has many partitions. Okay, it has many partitions. All right, now this is what we have. So there are so many partitions here. Now what happened was, after saying filter, right, after filter, nothing was basically the data. We are left with two less data. Okay, Okay. So here, after filtering, what we are left with, say, one element here. Okay. So instead of, so this would be having, by the way, this would be having many elements. Okay. These are RDD partitions. Each RDD partition can have many records in it. Okay, records is like lines in case of big.txt. So when we filter, let's say only one element is left on all of these, right? So it's better to basically repartition it so that it becomes really efficient. So when you say repartition, it will basically repartition, say, 3. Okay, so it'll basically leave us with only, you see, this kind of all right. So you can see only, say, 3 partitions are left. So after all of this shuffling, maybe only 3 partitions are left. This is 4 though. Okay, so only 4 partitions are left. So when we repartition, so data comes closer only and uses only 4 machines rather than traveling to all the having all the machines. Because if you run some logic, it will basically create one container on all machines, and that will basically unnecessarily use the resources in the network, and there will be unnecessary effort involved in shuffling from many machines. Okay, so therefore it's important to partition or repartition. Okay, sometimes you might want to use coalesce over repartition because coalesce is a little bit more efficient. Okay, this is how you control parallelism. Let's say this is what I was giving out. So we are reading a large amount of data from S3. After filter operation, we are left with only tiny fraction. Okay, now unless you call uh, unless unless you call coalesce or you call say repartition, it will still have the old number of records. All right. So this is how, this is a good example. So let's say this is our data. We have, first we checked how many number of partitions are there. Okay. This is S3 data, by the way. This is basically, we are reading data from there. So we have symbolically created these RDDs on all the machines. These are mapped RDDs again, mapped to AWS. And so mapped partitions basically. And the number of partitions you can see there are 35,000. And we said filter, okay, and when we say lines dot get number of partition, they'll be still same. And then in this case we should generally call coalesce and cache if we want to really use this data again, because if you cache it, then this filtering will not happen again, because here we are downloading data from AWS. Therefore this step could take a lot of time. Therefore, it makes sense to cache and coalesce, right? That's one form of optimization. So pay close attention to number of partitions, pay close attention to time taken in shuffling and the network transport. All right. So this is an example, a real example that we have done. So though this is done with PySpark, okay, let me just try if I can recreate this. So here what we did was without any coalesce, when we called, it took around 1.4 seconds. But when we did, we recreated into one partition, the overall time was improved. Okay, overall time was improved. You can try in your free time, right? So one was level of parallelization. So we talked about two things. One is how many partitions are created. So you can either coalesce or you can do repartition in order to fit into your requirements. Next is serialization format. Okay, while transferring or saving object, whenever we are transferring data, whether caching it, keeping it in memory, or sending it to somebody else, object needs serialization. What is serialization? Serialization is converting large object like this into bytes, right? The way when we talked about CSV files, talking about column orientedness, that time we talked about converting the complex objects into sequence of bytes. Okay, so there basically, so whenever we are translating a object, a complex object into bytes, we need to figure out on what basis we should pick up first object, and what should be converted into numbers, and what should be uh, 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 I mean, what should be the separator, and so on, right? Should we fix size, or should it be, you know, some other way? So there are many serialization. So there are many serializations that come into play in shuffling during class transfers. So there are many serialization formats available as of today. Okay, and by default, Spark will use Java's built-in serializer. And here is a list of serializers which are doing pretty good. Out of this, so far, protocol buffer is winning it. Okay, protocol buffer and cryo. These two are kind of winning it. All right. So these are the time taken, as per this benchmark. Okay. So cryo. Spark also support the use of cryo. It's faster and more compact, but but not all objects can be serialized out of the box. Okay. So almost all applications will benefit from shifting to cryo to use set Spark serializer in the conf object to cryo, and you can see the effect. Okay, while conf.set and set this variable to this. Okay. Also, if you want to optimize your classes, you can register your classes with cryo, and classes need to implement Java serializable interface. Okay, it doesn't matter in case of Python. So the other thing is a very common question that people ask, that what percentage of memory goes into what? Okay, pay attention to these numbers. So the entire memory of a container or an executor is divided into 60, 20, 20. Okay, your user code, which is running on every executor, because user code would contain the binaries, the classes and everything. So when you load these classes, they will be loaded into memory. They can compute, they can consume 20% of the memory. And while you shuffle or do anything, right, when you order something, there are temporary files, temporary memory, and so on, that can consume up to 20% of memory. While RDD storage, when you do persist or say cache, then 60% of the memory can be utilized there. So out of whatever container memory we have given, 60 goes to RDD persistence, 20 goes to shuffling and aggregation buffers, and 20 goes to user code. Okay. If in case of RDD, if let's say you are hitting the upper limit while caching the data, the older partitions will be dropped from the memory. Okay, and if you are not anyway, if you are not caching something, it will be recomputed on demand. Sometimes persist could be better with memory and disk kind of persistence while we talked about it, because if you're persisting something, it should go at both, I mean, if it goes to both the places, memory as well as disk, it is far better. Okay, because if you have really, really huge data that would not fit into the memory, then it's better to fit it into the disk. All right. Okay. All right. A question from Mohsin. So a question is, right. Okay, so I'm just wondering why Avro is not mentioned. Okay, so let's talk about Avro tomorrow. Let me make a note in my to-do. Okay, so let's talk about Avro tomorrow. We'll also talk about ParaQuick tomorrow. Okay, and all right. Sometimes remember that so far we have talked about three parts. One is partitions, second is format, and third is the memory management. Okay, so keep these in mind. If your RDD storage is being hurt and it's reaching to the upper limit, use memory and disk kind of caching. All right, so the hardware resources that you give to Spark will have a significant impact. For example, if the memory is higher, that will basically improve our persistence. Instead of spilling over to the disk, it will keep it in the memory. Okay, so that's how it utilizes. This is how it utilizes the memory better, because whatever is the memory allocated to container, 60% goes to this. So if more the memory, the more will be this area, and when you are caching it, it will keep it in the memory so that it is readily available. So the main parameters while you're deciding on hardware resources are amount of memory given to each executor, number of cores on each executor, total number of executors across the cluster, number of disks for immediate data. Okay, number of disks for immediate data. Okay, then is, so you can set the executor memory using this parameter that we have talked about. So as a thumb rule, even your laptop would benefit from more memory than actually anything else. Okay, so if you have more processing to be done, put more cores. If you have more memory, more requirement of data oriented computing, keep more memory. So ideally, when you put more memory and cores, your application will generally become faster. So Spark is able to achieve linear scaling, meaning adding twice the resources would make your application run twice as fast. Okay, that's linear scaling. Also, keep in mind that if you keep, say, really huge memory like 100 gigabyte, Garbage collector could start pausing, and that could be very dangerous situation. Okay, therefore the other syndrome which I see with lots of people, what they do is they would buy a huge ram. They'll buy a huge ram in a hardware, and then they'll run multiple containers on the same machine. Okay, now if you have huge ram on the same machine and a very low end a single CPU or twice CPU, what would happen is most of the time, this, since memory has to be cleared up, right? Memory has to be cleared up. Garbage collector would take pauses, because while garbage collecting, it would actually pause for a very brief moment the allocation of memory, and that could be dangerous. So try not to go beyond, say, 100 gigabyte in memory. It could be okay, or say 64 GB or less, actually. As per their recommendation, is 64 GB or less. So try to keep that kind of memory, because a general syndrome is more memory is better. Therefore, let's buy 200 gigabytes machine. But what it starts happening is the garbage collector starts hurting you really bad, because when garbage collector runs, it pauses all other threads, it pauses the memory allocation, and that's what kills a lot of processes. Therefore, it's better to have 64 two machines with 64 GB RAM instead of one machine with 128 GB RAM. All right, so that was quick overview of hardware provisioning. All right. Okay. All right. This is not visible to many people. So let me increase the font size. Okay. All right. Great. So should we start with the Spark SQL? This is a little more interesting. And yeah. Hi, Alvin, Manu, Mohit, Mohsin, Ravi, Shamit, Mahmood, Pradeep, RS, Srini. Thank you. Tegu. Should we start? Okay. Okay. Pradeep and Tegu are not around. Okay. So, all right. All right. So, very important points. Very important points. Let's talk about something new in Spark SQL 2. Okay, Spark 2 actually. So they now basically they came up with another idea called data frame. Okay, so on the left hand side, what you see is an RDD, right? It has records, 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 and records. Inside record, whatever is there, it doesn't matter to RDD. It could be a complex object, it could be tuple, it could be an array, and so on, right? So only the key value pair kind of is being treated, is getting a better treatment from RDD. Other than that, everything is opaque from Spark's perspective. The way we think of an RDD is an array. Inside an array object, it could be any complex object. Inside an array element, it could be any complex object, right? Or it could be unstructured data, semi-structured data, whatever. It could be JSON, it could be text, it could be binary data, and it could be anything. That's what is an RDD, okay? RDD is the representation of a list of things. Make sense to you? RDD has partitions and so on. All right. Now, to process each record, we need to code, right? We need to write code in order to process each record. While Spark came up with idea called data frame. It is very similar to our data frame. Actually, it was implemented in order to be compatible with Spark R so that people can use Spark via R, right? The way we can use Spark using Scala or Python or Java or say SQL. In the similar way, data frame was created in order for people to uh, use data in the form of data frame, because data frame is a data structure similar to database tables, okay, which was there in R already. So R already has something called data frame, which is same as database tables. Okay, it has columns, it has names, and you can operate on columns, you can slice the table, you can join the table with another, and so on. So you can do all kinds of magics in R on a data frame, and same is possible on the data frame provided by Spark SQL. Okay, you can do things like select ID from name equals to this. So you can see that same data frame you can operate either via SQL or via R. Okay, so that's a wonderful thing they have done. And you will notice that data frame is a great idea. It is basically one level more refinement of an RDD. In RDD, we don't know what's there inside each record. Here we know exactly that it would be columns, right? So data frame uh, is ensures that every column has a name, and each record is broken down into columns, same fixed size columns. So data frame, collections of data organized into named columns. Yes, Manu, we can create data frames from RDD. Okay, good, good. Data frames are distributed. Though each record of data frame does not get distributed on multiple machines. Okay, it's conceptually equivalent to a table in a relational database. A data frame in R or Python is same as the data frame in Spark. It's the same, conceptually same. You can construct a data frame using structured data files, JSON, XML, and you can also create data frames from tables in Hive. You will see how easy it is. And then you can also talk to external databases or using existing RDDs. Data frame API is available in Scala, Java, Python, and R. You will see, I'll show you that. Don't worry. Okay. So now there is something called Spark SQL. It is Spark's module for processing structured data. And the way we are clearly defining structured data, the data that contains columns, and we know the data types of each column. Okay, so there is a module because people realize that if we have our data structured in the form of tables or data frames, we can actually query them either our way using like programming language like R. It has a very great syntax for querying a data frame, just like SQL. Okay, so you don't have to write too much of code. You can simply query, and a single query is far better than writing too much of code. So Spark SQL is very well integrated, meaning it provides a programming abstraction called data frames, and you can mix SQL queries and Spark programs. So what you can do is using your Scala code, you can create RDD from anything. And then using Scala code itself, you can create a data frame and then use later on with, with SQL kind of syntax. Okay. Or some data you can load from Spark using Spark from HDFS. Some data you can load from a traditional database. Some data you can load from JSON, and then you can join them together by the way of data frames. Okay, this gives you enormous power. And if you ask me personally, if somebody asks me to do some structured or unstructured data processing, what would I do is I'll basically start Spark Shell and or PySpark, and then start creating my RDD, clean up the data. After cleaning up the data, I'll create my data frame and then start processing that data using data frame API or SQL. So that gives you enormous amount of flexibility. On one hand, you have got programming language with which you can clean up data, because cleaning up data or streamlining data requires a lot of coding and requires a lot of hard work. If you don't do a lot of coding, then you might end up doing a lot of manual work there. So here you get power of both sides, SQL as well as the traditional programming, okay, which was difficult in other ways. And you get interactivity of just like SQL. Okay, so it provides a uniform data access. Okay, from all kinds of sources. As we talked about, that Spark can read data from all kinds of data sources and so on. So once you have that data available in the form of data frame or RDD, you can mix and match and you can do whatever is possible. Okay. So it provides a compatibility with Hive. That is some interesting part. And it runs standard connectivity. So you can connect through JDBC or ODBC and whatever database you have, or you can connect to DBI tools. Okay. So let's try, I'll try some, uh, examples here. So what you have here is, this is the starting point. If you are using a program, then what you can do is you can use a builder, an app, and so on, the way it, traditionally whatever we are creating. And so using Spark session, we can create the 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 starting point. Okay, and from a Spark session, we can start creating RTD. Okay, so I'm going to start the process. I'm going to start from here. Okay, so all right. So what we're going to do is we are going to use Spark Shell for even the Spark SQL. Okay. So I'm going to exit Zookeeper and run. First of all, we are exporting this config, this config. Okay. What does it mean? We are telling Spark that this is where our Hadoop reside. Now, as I told you that you can install as many Spark versions as you want, I have installed this one, so that we can run Spark Shell. Okay, so we are running Spark Shell here. This is a newer version. The default one is not 2, is 1. Therefore, we are using 2 in this particular example because Spark SQL was introduced in Spark 2. Okay, so here, all right. So this is what we get. Now, please note that we get the Spark session under name Spark. Unlike earlier, it was Spark SQL. That was a little confusing. Now it's very uniform. It's called Spark. All right. What's the difference between these two? Okay, I think it's duplicated or something. Okay, so this was our starting point. Now I'm going to do something interesting. So let's take up this particular data. Okay, I'm going to show you this data. Okay, so we have e dot cloudx. This is where is our hue? Hue is on D, right? D. So I'm going directly to file browser. Okay, these things I can close, right? This I can close. This I can close. Okay. All right. So what we have, I'll go to the top label, then data. Then I have, what was the folder? Anybody? Data spark people.json. Data, not inside data. So please help me. Okay. Data spark and then people.json. Okay. So you can see that. What format is this? JSON. So a quick question to all. Is this entire document a valid JSON? Correct. Why? Because every line is a valid JSON, right? And either it should be an array. In that case, there should be a square bracket, comma, then square, and so on, right? So even though every line is a valid JSON, the entire document is just is basically JSON. Yes, unconnected is the right way to describe it. Thank you, Mohit. And yes, so basically this is each line is a valid JSON. Okay, now, all right, so we can simply call this method called spark.read.scalar, and it would read it. Okay, all right, and then we could simply say df.show. You see, so by default it did a very clever thing. It basically tried to understand what is there inside people.json, and then try to understand that, okay, every line is an object, and accordingly for each object it has created a record. There are three objects, and every object was an attribute, right? Name, age, and so on, right? Now also it did a very clever thing, which is something very interesting, is it deciphered the name of the column headers. Even though age was existing only in these two records, not in third record, still it was able to figure that out. Yes, I'll paste that code. Okay. Sounds cool. Okay, so now we did not have to write too much of code, but imagine that instead of this being a proper object, what if there were array of things or something else? Yes, I'll send the initial two settings also. Okay, thank you for reminding that. So we are going to use the first one for now. Okay, and then we are saying this. Good. All right. Now, I think it's better to run it non-full mode, because if I'm in full mode, I'm not able to copy paste. Okay, good. So we were able to kind of parse and load the JSON data, right? You can similarly load the data from Hive table. You can load the data from Paraquay table. The Paraquay is another form of is another format like JSON or CSV. Okay, so now, so the other thing you can note is there is something called df dot, or better thing even is just press dot and tab. It will show you all the possible things that you can do on top of data frame. You can do flat map, for each, repartition, sample, and so on, whatever you could do on RDD. Okay, so there is something called to JSON or to, so on any RDD there is a way to convert that into a data frame, okay, by using df. Similarly, it has order by, join, and so on. It has filter, everything is there. So you can see there are many more functions than we had thought. Okay, so we can say print schema. Okay, so it is saying that both are nullable, and this one is long and this one is string. So the wonderful part was that it figured out by scanning JSON that this one is integer and this one is a string. Okay, and now you can also do things like select. This is the way our operations are performed, right? This is the way we perform our operations. Okay, we are saying give me first column. Okay, and then we could say show. See, so we can cleverly create these new data frames from the existing one. So we could say where first column. Okay, sorry. Okay, so we have first column. So this is another data frame. You can see that. And all right, so you can also try this if you want. And we can say fc.show. All right. So either you are from the R background or you are from SQL background, you will feel at home with data frame. There's a clever thing what they have done. There's a very clever thing they have done. And this is the reason why people are adopting to Spark and Spark SQL, because you can on one hand you can write a scalar code. On other you can write SQL parallelly. You can also write R kind of syntax, right? So and that gives you this huge power. Okay, and it's not like it's a very hard thing to go back and forth between data frames and map reduce and flat map. You can do it all the time. Okay, all the time whenever need. Okay, so if you want to do say filter on SC, okay, we can run filter. we can create our method called filter. All right, which is our standard way of coding. All right. Also note that unless we said show, it did not do anything. It just created another things. Okay. So we can do far more complex the operations on a data frame. Like we are saying, increase age by 1. You can see increase age by 1 and select the name. Okay. These are the standard syntax from our background. Okay. So people, the data scientists who are pretty good at R, they are happy with this, while the engineers who are good with SQL, they're happy with calling SQL on top of it. Okay, I'll show you that part as well. And the engineers who are good with programming, computing, or if their need is complex, let's say something that cannot be achieved with SQL or R, they want to iterate through the record, they want to distribute in their own custom way. Those things are anyway possible using standard flat map and other operation that we have learned. Okay, so you can see that we are able to do complex operation. We can further do filter here. df.filter is greater than 21. Okay, and we can say group by. Okay, unlike the biggest difference you will find if you're coming from our background, biggest difference you will find is this show method, the show method has to be called. Otherwise, it will just create another data frame. This portion will only create another data frame. It will not really bring data to you. Okay. Okay. So here we have grouped the data by age and then shown the count. Now, yes, we can do the join across the data frames. All right. Now I'll show you some things. And let's say you're done with using R. You don't want R. You want to use SQL. What you can do is any data frame can be registered as a table. Okay. You can say create or replace temporary view. Now, what you can do is you can simply say spark.sql and select start from people. Okay. Now SQL data frame. So everything is returning a data frame. This was a data frame when we registered table. Okay, we registered it as a table. Only then we are able to call this particular SQL. Now you can simply say this. See that? Or simply what you can do is you can say this. Sounds good? So now what we did was after, okay, I'll just copy everything. Okay. All right. Are you happy with this kind of model? So, but remember that a data frame need to be first registered, right? Create or replace a temporary view. And then from this view, we can query. Okay. Also, an important part is here, you can register the data frame from like 10, 15 files, or one file from S3, other file from HDFS, and third one is a table from HBase, fourth one is from MongoDB, and you can join them together. And that's the beauty of it. Okay. All right. Now there are two ways to convert RDD to data frame. That's another question from somebody. So the first one is Spark SQL can convert an RDD of raw objects to a data frame. What does it mean? So if you create an RDD in your logic that contains raw objects, every record in your RDD, what you did was you ran a map function, and inside the map function, you created raw objects. Okay? Then you can simply say 2df and it will create the data frame out of it. All right? Let's try to see this file, people.txt. We have a file here called people.txt. Okay, people.txt. You see, it has two things. It's a comma separated file, or maybe we don't know what's there inside it. Let's try to convert this. Okay, so here I'm using this particular piece. Okay, I'm also pasting it on the chat. Okay, I'm going to say, okay, so we have created expression encoder. Sorry, we have imported expression encoder. It's basically required for internal. This is something for implicit conversions between RDD and this. Now, here, remember that we are trying to create basically a person class, right? And just a second, let me try to see if a row can be. Okay, I'll have to see that part. Now, let's say that we loaded a text file. We call it text file, t equals, and we say sc.text file. Good. Now this t dot take 10. What does it have? It has our Michael, Andy, and Justin. We have read it from here. This is what we did earlier, right? Load something from using text file and then run it. Now, next thing we do is we split the records based on uh, the data. So we say CSV, or we can say to array, okay, equals t dot map. Okay, sounds good to you? All right. Now, what does it do? It broke down the work into an array of values. You can see it's an array here of arrays, correct? Earlier, it was an array of strings. It was an array of strings. So we have broken it down into array of arrays. Sounds great, right? But here you notice that this is still a string in the double quotes, right? Next, what we are doing is we are going to create this person object. Okay, we're going to create a person object. And then we are going to say 2df. If we try to say 2df on this, let's see, let's just do this, where x equals to array dot 2df, what would happen? Okay, so it's actually confused. It doesn't know what to do with it. Okay, let me show you. So each record right now is not broken. It is just array. You see that there's only one column right now. Therefore, we need to convert this into an object. We need to say to array dot map, right? We need to say to array dot map, and we will call this RDD as persons. I'm just breaking down into steps. Okay, so uh, error value not found. I think we forgot to create this class. Okay, now we have persons, right? Let's take a look at persons. Persons is an RDD. Okay, you can see that it's an RDD. Okay, it's a mapped partition RDD. All right, and then I say take. Okay, this is how we did things. So here it shows that there is one person, there's another person, and there is another person. Good. Next is we can say simply persons dot to data frame, and we save it. We give it a name called persons data frame, PDF, or persons data frame. Okay. Now what we get is this data frame called persons. Now if we say show, it has created a property table. Yes. This is called data converting from unstructured to structured. Okay, a question from Manu, that how did it get column headers from text? It did not. Okay, it did not. It's us who did that. We defined a class with two variable name and age. Okay, yes, you got it right, Manu. So we defined name. All right, and these are the ones that it has picked up, because first we translated our this text file into this objects. Every record of this text file was converted into this. Sounds good to you? And now, once we have created this data frame, persons df, we could do all kinds of magic. We could say things like select $age +1. This is how it does, right? I'm not great with all right, and then I say show. You see, it has done the job. 30, 31, 20. Good. So we can do all kinds of churning once we have created the records. Okay. Earlier, in case of MapReduce, we would finish all kinds of unstructured data to structured data conversion, save it somewhere in the file, then again load it in Hive, then again process it using SQL. That's just too big a loop. Here, everything can be done from one place, from one single program. All right. All right. So similarly, you can see that the same person's DF, whatever we have defined here, we can register that. We can register that as a table, right? We can say create or replace table called people. Now, once we have registered it as a view or table, yes, in case of JSON, it actually picked up the column header from the object definition in the attributes of the object. Now, what you see is, as earlier we had clearly defined the columns and everything, now we can do complex queries like select name, comma, age from people where age is between 13 to 19, right? And we can say teenagers df dot show. You see that? Or you could run MapReduce our traditional way. We could say map teenager as the argument that's coming in, and then name and show. Okay, so you here have a good. So in case you forget to assign it to something, this is the variable it get assigned to, and then you can use that. Okay, so we are concatenating the name colon on every name. Okay, so this is the teenager df. If we want to do the same thing for say persons df, right? What was that? People df. What was the data frame that we were creating? It was persons df. So what I showed you is that initially we used our unstructured way of RDD. Once we were done with creating object, we created a data frame. And then from the data frame, we registered as a SQL table. And then we queried using SQL. Okay. Then we got the data frame. Then we again ran MapReduce here. Uh, and we got the results. Good. Okay. So this was one way of creating the data frame. The other way is inferring the schema using reflection. Okay, so this is another way. And okay, so sorry, we are still using the old way. All right, no worries. So further operation, what you see here is we have done. We can do further operation of using scalar, like convert something into string and then process it. Then if you want to, now if you he, now here, okay, so here we're defining our encoder for cryo, okay, that we can use further. So when we register something here like implicit, meaning we are overriding the default behavior of encoding. Okay, we are overriding default behavior of encoding. Okay, so when we save it, it will basically use this particular encoder. All right, next is we are getting something as this. The other way is to programmatically specifying the schema. Okay, and we can specify the schema by defining a structured field, row field, and so on. Okay, the approaches are similar. And the difference is that there we create a separate case object. Here we are creating a row object. All right. And we are filling in the schema separately. Okay. So here we are saying schema string is name and string. And then we are breaking it down and defining it. Okay. All right. So that's about creating data frames. All right. Spark SQL supports operating on variety of data sources through data frames interface. Is everybody okay so far? Were you, how many of you actually tried the JSON example? Good, good. Only Srini did. All right. Okay. Okay. Is that George with CST ADM? Okay. So yes, great. Great. You must try it. Okay, that'll give you these examples. What I am mentioning here, they are in the LMS as well. So you must try these examples because they will give you a good freedom of thought. Okay, go through line by line and try them again. They should give you a good confidence on the library. All right. Now, so So you can a data frame can be operated as normal RDD and also can be registered as a temporary table, and it allows the SQL queries if you register it as a temporary table. Okay, so there is a Paraquay format. It's called user.paraquay. Here, one file which we have created is with the name users.paraquay. Paraquay. It's basically Paraquay means under the flooring there are blocks and the flooring is covering those blocks. Okay, so let me go back. Which one? We are talking about users.paraquay. This is that file that we are talking about. Okay, all right. So you can see, let me just copy it to local. Okay, and then, okay. So let me open another console and then say, Hadoop fs copy to local. And when we say users.paraquay, it says it's a Paraquay archive. And if you take a look at what's inside, it'll be binary data. You can see that it's a binary data. Okay, so Paraquay is a format in which the data is stored either via Avro or other mechanisms. All right, so here what we are saying is load spark.read.load. Okay, so by default, it would try to infer the data as Paraquay. Let's see if it does. Okay, let's see if it does. We are saying where df, and that's it. Okay, what does it say? Error looking for metadata directory. Error looking for metadata directory. And let me see what is df dot show. Okay, so it has actually read the data from the file. You see that? Okay, that's the data that is there in the, yeah, those are the warnings because we are trying to automatically cast it and so on. Okay, and context is not an instance of task input output context. All right, so let's ignore the warnings. So now we are saying df is equals df.select. Now the new df that we got, we are saying just pick the favorite color column from the data frame. So name and favorite color column, that's what we have picked. Okay, and then we can save this result into our home folder. Okay, why? It says already exists. This file already exists, so we'll just delete it. Say Hadoop fs minus rm. Okay, so it's actually a folder, not a file. All right, so it must have saved it here. Let's take a look at it. It has saved it here. Okay, here we go. Here, so it has created a folder like this, which contains this format. The rename, download, or is there a way to open it? No, you can't. You can't. So you have to download it locally because it doesn't make sense to read a binary file in the browser. Okay, does it make sense to you? So I'm just trying to demonstrate how can you read, say, JSON file, Paraquay file, and so on. This one we have already. So spark.read, there are two ways to load things. Either use, say, spark read JSON, spark read load, or you could say spark read format, and then you get this format and then use the load function of that one. Okay, so all right, maybe we have to delete this first. Okay, now if we have, it has saved the data, but the data is saved in that format, Paraquay format. Let me just say Hadoop fs copy to local. Okay, so this is that folder and this is that data. All right, you can see that it has some binary data. All right, so this is the way we have loaded the Paraquay format. Similarly, once we have the other way is using Spark SQL. You can simply say spark.sql select star from Paraquay dot this file. This is something very easy and useful. Okay, so we go to the place. Okay, so it has loaded the data frame, and we can simply say show. All right, or we can say here name comma favorite color. Okay, this is what we have written. All right, now this time it has got only favorite color. Okay, just that the third column has been dropped. Okay, so this is quite interesting. This is very interesting, and similarly you can directly load a format. Now the other part is that you can load Hive data. You can load Hive data, and very simply you can simply say okay, so let me just take a table. All right, so we have, so we can simply say things like, okay, we have imported this SQL function, so we are calling this. All right, and here this data frame dot show. Remember this employees table? Employees table is there in the path does not exist. Okay, so I think the table is not complete. Let me pick up any other table. Okay, so we have Hive. So okay, so let me just go to Hive, pick any table from default. Okay, so in the default, let me just pick up any table. How do I find which one has data? Does cars have data? select star from cars. No, it doesn't. Okay. So category is having some data, this data. So we can simply go here and say things like select star from and then show. Good. You can see category, category name. Okay. And what were the tables that we had registered earlier? Let's say persons table or people's table. What was the name? People. Yes. So we have, let's say, two tables. Okay. So we could join people with category. Okay. Do you see some magic? It's only showing top 20 rows. Okay. And we can also further say things like right, basically it is showing us only first few rows. We can save the results and see the entire thing. Okay, it has joined the two tables. Now this people is coming, he has come from JSON, while this one has come from Hive. So we are able to query together. We join these two tables actually. Okay, so can I say something like 1,000? Yeah, now you can see. So it had basically done join of Michael with action, Michael with all of the movies, then Andy with action, and so on, and with Justin with action and all. So you can see that we have done the joining of two tables from two different data sources. Okay, does that impress you? So this is a very important aspect of data churning, because this is a single tool with which you can actually query all kinds of format in either R, SQL, or raw Scala. Similarly, at the same time, if you don't like Scala, you can use Python or Java to write your logic. Let's say you have certain library that is there only in Python. Let's say you are doing some movie kind of things and there's a movie pie and you want to do that. So you can actually join all of these data together without exiting the the interpreter. You can actually interact with all of these. Okay. Similarly, you can try to interact with MySQL, MySQL, if you pass the driver on the console. Okay, if you pass the driver to console, we can talk to MySQL, and that should be, you can connect some data from SQL, say MySQL, some data from Hive, some data from HDFS, some data from JSON object, or some data from S3, and you can combine all of these together, and that should be very useful. Okay, so here I am trying to connect to my database. Okay, all right, I'm sorry, I need to convert this into a single line. Okay, I need to convert this into a single line, and the best way I know is regular expression. Okay, so I'll say replace new line with nothing. Okay, what we do is that's it. So we have converted entire thing into a single row. Okay, so there we go. So what does it say? We are getting some error. It says no suitable driver found. Did we make mistake while starting? So it says my connector. Okay, I have put the connector at this location. You might want to. Okay, so good. Sorry. All right. I'm sorry. I think I messed up. I should have just executed this. No worries. Actually, it skipped the rest part. Ignore this part. Never mind. Now we go back to what we prepared. We prepared this query. Let me show you this. And I'm sorry, we are running a little out of time, but just last point. All right. So we have loaded this data from this SQL one. You can see that. Yes. You want to see the actual data? We will connect to MySQL. Okay. We'll connect to MySQL and then go to this database and then see this table. All right. And let me go to another one. And how do you connect to MySQL? All right. Yes. So when I connect it, so you can also connect to MySQL and try. And then on the other hand, we are first copied this jar to local because it needs it to be local. So we have kept this MySQL connector available to all our users. Now let's just take a look at this particular table. Select star from DB table. Yes. So here we go. All right. So this is the table that we are querying from here. Now, this is not it doesn't end here. So what we can do further is this frame, we can register, we can, you can say, create, or what is that function? I forgot. Okay. We say create or create or replace. Okay. It's actually earlier it used to be create temporary view. Okay, we are saying JD or we say J widgets. Good. And then we can say SQL or we can say spark.sql select star from J widgets. Okay. So res9 is the temporary variable that it has been created. And I say, good. So basically what we are trying to do is we're trying to show you that you can actually do all kinds of magic just from here. Okay. You can see that. Good. Now, okay, Srini's question is, can you paste the code? Yes, definitely. This one or this one? All right, let me just complete this code for you. All right. First, you copy the driver to your local directory from our HDFS. That's a common place. We have kept the driver for all. Then you create. You basically connect to you basically launch Spark SQL with extra jar, as I was telling you, that you can hand over your jars to Spark by the way of jars variable, and also you can mention the driver class path name, and then you can call the JDBC. Okay, sounds good to you? And once done, you can say jdbc.show. All right. If you're looking for connecting to MySQL, that you can connect to MySQL separately as I have pasted earlier, and that should be. So here is something. Okay, I think I have missed a couple of queries, so I'll just take 5 more minutes to answer the queries, and we will be through. Question from Srini: what is that not possible from Spark? So I think all kinds of data churning are possible, just that it does not provide any storage or kind of updates to the data. All right. Now, RS's question is, don't these joins will be expensive? They'll be slightly expensive, but Spark tries to optimize a lot of things, okay, and tries to do the data locality whenever possible. All right. Next question is loading reference to MySQL or data? It's loading reference, okay. Unless you call show, it doesn't do much, okay. It doesn't do much. You can see that if I just execute it, it'll finish very quickly. Okay. So when I say this, it finished quickly. And when I say show, then it basically connects. There is a lag of a second. Okay. Now what we saw was that from data frame, we could read JSON, Hive, RDD, text file, Paraquet, and then we could do filter select in the R format. We could do SQL format and usual RDD flat map and filter and all kinds of magic that we learned in RDD. So data frame kind of completes our way of understanding. So 90% of the unstructured data you handle with the usual RDD, and the structured data, once you are ready with the structured data, then you can do all kinds of magic with filter, SQL, and so on. All right. So that's pretty much. And there is something called Beeline. Using Beeline, you can connect to the to Hive basically, and interact with the tables. Okay. So we will talk about Spark R tomorrow at the same time. All right. We will also discuss about the project. If you have formed the teams, we will list down the teams, and then we will also start with the project tomorrow. All right. So it was a wonderful session. Thank you for great questions. I look forward for you to see in tomorrow's session. ML and Spark, Spark R, ML Lib, and GraphX. We will talk tomorrow. All right. We have already talked about R, so we would not get into too much details. And yeah, we'll go into GraphX and MLlib tomorrow, and general overview of machine learning and artificial intelligence. All right, along with the project description. See you tomorrow at the same time.